Okay, now we're going to be doing power of powers. So again, if you think back to the exponent rules of the previous unit, we've already done stuff like this. And when we did power of powers, we had to distribute that power on the outside to all the powers inside. It's going to be the same idea here. So right now we have 4.7 times 10 to the 6. So students generally get this part just fine. They multiply the 4 and the 6 together. Problem is they sometimes forget that there's a 1 above that 4.7. So the 4 has to distribute to that 1 as well, making it 4.7 to the 4th power times 10 to the now 20th or 24th power. Okay? Then we're going to actually have to raise this to the 4th power and then move any extra 10s we have over to this side. So, for example, it would be 4.7 to the 4th power, which is 487.9681. So 487.9681 times 10 to the 24. So you'll see that we have 2 extra 10 spots that we need to get rid of to get this number between 1 and 10. So that it becomes 4.879681 times, and I'm going to take those 10s, put them on top here, and since I'm taking away here, I'm going to add them up here. So it'd be 10 to the 26th power. And that would be that number right there. So in standard form, I'm not going to write it out here, but you move the decimal spot and you're going to get a bunch of zeros. It's going to be a very big number. You'll find that getting big numbers is something that's pretty common with power problems. So you'll love these, I'm sure. All right, let's look at another one. Let's look at number 2. So we've got a negative number on the outside, which means it's going to be making this number very small. But let's look at it. So that negative 4 is going to distribute to the 4, and then it's also going to distribute to the negative 1 there. Okay, so I get 3 to the negative 4 power. And then I get times 10 to the negative 16 power. Okay, 3 to the negative 4 power gives me 0.01234567.9. Okay, it's probably 89. It's probably just going up. But I'm just going to take the first few numbers there. So it's going to be 0.01234. Okay, and then times 10 to the negative 16 power. So again, I need the number in front to be between 1 and 10, so the decimal is going to move 2 spots over, which means I'm going to be making this number bigger, which means I need to take 10s away from this side. Okay, so I'll be taking 2 more 10s away from here. So 1.234, and then if I subtract 2 from negative 16, it's going to become 10 to the negative 18. And that would be my final, and I need this in standard form, which means I'd move 18 spots over. Well, let's do it. So it's going to move 18 spots over, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 2, 3, 4. Okay. It's a very small number. Let's do another example here. So here's a good example. So this one is not in scientific notation. So I don't have to put this in scientific notation before I do this. I can just do this and then put it in scientific notation, although sometimes your calculator won't be able to handle it. So let's see if this is a small enough number. 4,000 to the 6th power is too big of a number. So we are going to have to put this in scientific notation. So we're going to move the decimal spot over 3 spots. It's going to become 4 times, 4 times 10 to the 3rd power, and then it's going to be raised to the 6th power. And then we distribute the 6 to both the exponents, and we get 4 to the 6th power times 10 to the 18th power. And 4 to the 6 our calculator can handle, so 4,096 times 10 to the 18. And then I've got to convert it, so 1, 2, 3. Going to take 3 10s away, so that it becomes 4.096 times, And then I'm going to take the 3's, 10s and put them over here. 3 plus 18 is 21, 10 to the 21 power. Yeah. Okay, and then again in standard form, oh boy, it's going to be 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I ran out of space. So those zeros are at the end there. Okay, but that is basically what you do for power of powers.